Virtual methods are a powerful feature of object-oriented programming that allows subclasses to override the behavior of methods defined in their base class. I will now show you how that works in C#. There might be a base class. In this demo, we will model a bookstore system that lets you borrow some books. A publication would have a unique label, which we use to count and track items in the store. It would also have a title to display in all places. Now come the variants, which we implement as subclasses in C#. One variant is the book. It also has the author's name. The other variant is a magazine, with its specific representation, the issue number. Where are the virtual methods here? What are they useful for? We use virtual methods to implement a variation which depends on a concrete type. For example, every class in C# inherits some virtual methods, like toString. We can re-implement toString in any class using the override keyword. Let's try these classes out. Here are the two sample objects. If we passed each of the publication objects to the WriteLine method, for example, it would invoke our custom toString implementation to format the output. How convenient! But there is more to virtual methods than meets the eye. The decision of which method implementation to execute at runtime is made from the object, not from its type. We are looping through instances of publication, but none of the objects is exactly a publication. It is either a book or a magazine instance. We can re-implement the toString method in these two classes as well, adding a different flavor in each case. A book would also display its author. Please observe how this implementation uses base method implementation to complete part of its work. You can use the base keyword to access a method implementation in the base type. That would either be a method truly implemented in the base type or a method the base has inherited from its own base. A magazine would advertise its issue number. The loop above would use one concrete implementation or the other to print specifics of any publication. You can define your virtual methods too. Let's spice this up a bit. Users wish to borrow publications, and we are modeling that with an interface that tries to place a reservation on an item, given its label. But borrowing also depends on the concrete item at hand. You must buy some publications if you wish to take them away. Virtual methods solve the problem of behavior that varies by a derived type. We declare a virtual method on the base class using the virtual keyword. This virtual method returns a Boolean indicating whether the borrowing operation was successful. You are free to provide a full implementation of a virtual method like any other. For instance, the base implementation of this method could always return false, indicating that the default decision of the bookstore is not to allow borrowing. Suppose we want to allow borrowing of books through a reservation system. We can override the tryBorrow method to call the reservation system and attempt to reserve the book. Note that we use the override keyword again to indicate that we are overriding the base implementation of the tryBorrow method. Then we get to magazines. We don't want to allow borrowing magazines. The magazine class inherits from publication, and it already has a fully implemented tryBorrow method which returns false. That is what we wanted, right? So we can leave the inherited tryBorrow method without overriding it. And that's it. We've successfully used virtual methods in C# to allow subclasses to customize the behavior of a base class method. Don't forget to like this video and subscribe to my channel for more videos like this one.